In this video, which is the second video of tangents and circles, we're going to focus on circles with a tangent to the circle, but the point on that tangent is outside the circle. So they give us a point outside the circle. Okay? So generally what they could ask us is for the equation of these two tangents. Okay? And they just give us a point outside the circle and also the equation of the circle. Okay? And they will ask us then to find the equation of these two tangents. And the second type question they could ask us is to find the distance between this point and where it touches the circle. And I suppose a trick that we need to be aware of when doing that is, if I join this where this tangent hits the circle straight back to the centre of the circle, and if I join that centre of the circle back to that point outside it, notice that this here, okay, so I'll do it in blue, this here is a right angle triangle, and if it's a right angle triangle then the rules of Pythagoras' theorem will govern it. Okay, so in that type of question we will be using Pythagoras' theorem a lot. Okay, so our first question, and this type of question is probably the most difficult in the lot to do with regard to tangents and circles, and unfortunately it's the one that comes up most often in the exam papers. Okay? This kind of a tangent with a point given outside the circle. So off we go with it anyway. So it says find the equations. So equations, so straight away we need to read our question carefully. Equations, so that means there's going to be two of them. Of the tangent of the circle, x squared plus y squared equals 5. So we know then the centre of the circle is 0, 0. Okay, it doesn't have to be 0, 0. It will be just as easy to do this question with a circle that isn't 0, 0. But find the equations of the tangent of the circle, x squared plus y squared equals 5, from the point 5, 0. First thing I'm going to do is sketch. Okay, and always do a sketch of these. So there's our point. We have a tangent to the circle, so there's our circle, x squared plus y squared equals 5. Tangent to the circle from point 5, 0. And so point 5, 0 will be, say, out here. And we have two tangents, so here's one. It's going to hit the circle at one place. So there. And here's the other. Right, and this here is 5, 0, and note that this point here is 0, 0, and I want the equation of these two tangents. Right, and we don't have the equation and we don't have the slope, but we do have the point on the line. So let's try get an equation with what we have so far. Okay, so again we're looking for the equation of these two lines. We don't know their slope, so that's the problem. But let's start off with y minus y1 equals mx minus x1. Okay, so that's the equation of a line formula. And this will be x1 and that will be y1. So let's put in what we know. So y minus 0 equals m, we don't know what it is, we don't know what the slope is, of either of the tangents, x minus x1, which is 5. And that will give us y equals mx minus 5m. And what we'd usually write, we'd write it in this form then, minus mx plus y plus 5m equals 0, and remember I hate starting with a minus x, so change the signs the whole way across. Okay, so there's our equation of a line, but the only problem is we don't know what m is. If we knew what m was, which is the slope of each of these, well then we'd be able to find out what the two equations are, but we don't. However, let's have a look up here. We do know that that point is 0, 0. We do know that the distance from that point to to that tangent there, or indeed that point to that tangent there, is the square root of 5. Why? How do I know that? Well, because this 5, that's the radius squared, so the radius must be square root of 5. So the distance from this point 0, 0 to this line, the perpendicular distance from that point 0, 0 to that line, is the square root of 5. Okay, that's all the information I need. Because if I take the perpendicular distance from a point to a line formula and let it equal the square root of 5, the only unknown there, the only thing I don't know is m. So that means I have one equation, one unknown. I should be able to solve it. Right? So let's start with our perpendicular distance from a point to a line formula. Okay, so that formula is from the log books: ax1 plus by1 plus c, that's the modulus of that, all over square root of a squared plus b squared. And we're going to write down what a is, b is, c is, x1 and y1 are. So, and let's look at this equation. So, our a is going to be the number in front of x, which is m. Our b is going to be the number in front of y, which is minus 1. And our c is going to be minus 5m, so this value here. x1 then, we go back to our point. x1, oh sorry, here's our x1 and y1, so x1 is 5, y1 is 0. We then will take that formula, slot everything in, and let it equal the square root of 5, which is the distance between that point and that line. Actually, I have made a mistake there. Just 1 sec, go back here. It's this point to this line, so therefore that's x1 and that's y1 for the purpose of this formula. So that's x1 is 0, y1 is 0. Okay, so let's throw it into the formula. A is m, x1 is 0, plus b is minus 1, y1 is 0, plus c, which is minus 5m, all over the square root of a squared, which is m squared, plus b squared, which is minus 1 squared. And we will let that equal root 5. I don't need this anymore, so I'm just going to tidy it up and get rid of it. Right, so now it's just algebra. The only thing I'm missing here is the m. Okay, so this is one equation, one unknown. I should be able to solve it. So m multiplied by 0 is 0, minus 1 multiplied by 0 is 0, minus 5m, all over the square root of m squared, and then minus 1 squared is 1, so plus 1, and that all equals the square root of 5. So just tidying this up then, I'll have the modulus of minus 5m all over square root of m squared plus 1 equals the square root of 5. I'd love to get rid of all these square roots. I can do that. I can square everything. Okay? Just if you have a look over here, 6 over, we'll say 2 equals 3. If I square everything, is it still true? 6 squared is 36 over 4 equals 4 and 6, 9, and that's the same as 3 squared. So I can do that. So I'm going to square the top. Right, so let's square it. So the top, forget the modulus, right? So let's just take 5m or minus 5m, whichever you want, squared. Well, 5m all to be squared is 25m m squared. Okay, and the bottom square then will just leave us with m squared plus 1, and squaring this we'll get 5. I'll multiply the left side then by m squared plus 1, and I'll be left with 25 m squared equals, and multiply the right side with the same, and I'll be left with 5 multiplied by m squared plus 1. So that will leave me 25 m squared equals 5m squared plus 5. So take 5m squared from both, and I'll have 20m squared equals 5. Divide by 20 on both sides, we'll have m squared equals 5 divided by 20 is a quarter. So m squared is a quarter, so m equals a half or minus a half. Okay, if we think about it, a half squared is a quarter, but also minus a half squared is a quarter. So the slopes then we have a half and minus a half. So we have the slopes. So look up here. One of those slopes is going to be a half and the other is going to be minus a half. So we're nearly there. We take our y minus y1 equals x minus x1 formula, and I'm going to do two sums with the slope being a half and the slope minus a half. And the point for both was, if we look up here, point on the line is 5, 0. 5, 0. Okay, so let's start with this one, with the slope equals a half. So y minus y1, here's x1, here's y1, so 0 equals a half x minus 5. We'll then get 2y equals x minus 5. Tidying that up, minus x plus 2y plus 5 equals 0. X minus 2y minus 5 equals 0. There's one of our equations. The next one, y minus 0 equals minus a half x minus 5, and the minus a half, we'll say the 2 is the minus one, so we get minus 2y equals x minus 5, minus x then minus 2y plus 5 equals 0, x plus 2y minus 5 equals 0. So there is our two equations of these two tangents. Okay? Right, next question. Find the length of the tangent from the point minus 5, 8 to the circle x squared plus y squared minus 4x minus 6y plus 3 equals 0. Okay, first of all, let's sketch it out. Oops. So here's our circle. And let me think, what's the center of that circle? Well, take this out, so minus 4, half at minus 2, change the sign, 2. Same with the 6, take it out, half it, change the sign, 3. So, there's our center, and the radius then will be square root of a squared plus b squared minus c. Okay. Or if you want to do it, well actually, you know what, it's better probably saying f squared plus g squared minus c. Okay, so f is half of this, so that's minus 2. So minus 2 squared plus g, which is half of that, which is minus 3 squared, and c then is that, so that is minus 3. So we will get minus 2 squared is 4 plus 9 minus 3, which is the square root of 10. So the radius equals square root of 10. Okay. We have a point out here then, somewhere out here, doesn't matter where, and it's a tangent to the circle. So let's just say it's a tangent at this point. Okay, and that point is minus 5, 8. And we know that from here to here is the square root of 10. We know that because the radius is the square root of 10, so therefore from here to here is the square root of 10. If I join that point to the centre of the circle, I now have a right angled triangle. Look, here it is. I can easily find the distance of this side. I'll just use the distance formula to get the distance between the point 2, 3 and the point minus 5, 8. Okay? Using your distance formula then, you will find that the distance of this is the square root of 74. Okay, just make a bit of room for myself now. So I'm just going to draw out this triangle. Here's my right angle. This is root 74. This is root 10. I don't know what this is. It's a right angled triangle. I'm going to use Pythagoras' theorem to find out what this side is. So here I go. H squared equals a squared plus o squared. The h is this side, the o and the a are here. So h squared, so it's root 74 squared equals a squared, which is root 10 squared plus o squared. Root 74 squared is 74, root 10 squared is 10 plus o squared. Take 10 from both sides, 64 equals o squared. So o is square root of 64 and square root of 64 is 8. So this here, the distance between this point and the circle is 8. Okay, thank you.